Okay, this is a solution to problem 6 from the online homework G, and it also is using the applet or tables to find proportions or probabilities for normal distributions. The first question is asked about the z-score for a particular reading, and so to find a z-score, we need to know the mean and the standard deviation of the distribution, and you can see those are given up here. We would use the Greek letter mu for the mean and the Greek letter sigma for the standard deviation. And so a z-score of 140 is going to be the observation, the thing we're trying to get the score for, 140, minus the mean divided by the standard deviation. Don't forget that you need to do the subtraction first in the numerator. 140 minus 123 is 17. And then divide that by 14, and you get 1.21. I think it's 1.214, so it would round to 1.21 to 2 decimal places. So in the next question, it asks about the proportion of the population that suffers from high blood pressure, and so we have two choices. We can either draw, well as we can either draw a distribution with the parameters for the initial problem. That would be a mean of 123, so that'd be the center, and our 1, 2, 3 standard deviations. 1, 2, 3 standard deviations are going to be 14 wide, so add 14 to 123, you get 137, and over here you get 109, and so forth. So we could fill that in, and so that would be a distribution of blood pressures, and so we could interpret high blood pressure as just where we have 140, so I draw a line here at 140 and above. So 140 and above would be high blood pressure, and so I can visualize it on that graph. The alternative is to visualize this on a standard normal distribution, which would be the z-score distribution. And so if I'm drawing z-scores, then a z-score of 0 would be the middle, that's the average, and then 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. These are just the numbers 1, 2, 3. So that's what a z-score distribution looks like. And that is what your table will always be, the table will always be measuring this kind of distribution. So if we're drawing this, these are the z-scores, then I need to place on here the actual z-score of high blood pressure. High blood pressure starts with a z-score of 1.21. So that's about there. And anything above that would also be high blood pressure. So these graphs ought to be identical except for the scale on the bottom. And so that's why we can use either one of their settings to get the answer to the question. So I will go to the applet. If you're sitting at a computer, the applet makes a lot of sense. You'll see the URL for the applets at the top there. And you'll notice that I've gone to the Find Probability tab, and I've got a cat next to me, so please disregard meows. But I set this up so that it has the mean mu 123 and the standard deviation sigma 14 that are in the specifications of the problem. Then I say I want the upper tail, meaning I want the shading to be to the right, which is the way I drew my picture, and the value of the vertical line should be at x equals 140. So that's what's drawn here, 140 going up. Notice this looks exactly like the picture I drew. I didn't label these values, but we could have. Those are just going up by 14s. Anyway, so 140 is right there, right above the first standard deviation. And everything to the right has an area of 11.23%, or as a proportion, 0.1123. In this applet, I could make this be a picture of the z-score distribution by, instead of having mu equals 123 and sigma equals 14, having mu equals 0 and sigma equals 1. So that's the standard normal distribution, centered at 0, my solution. And you can see here I have set this up already to match my first picture. I've set the mean to be 123 and the standard deviation to be 14. And I want an upper tail probability, meaning I want the shading to be on the upper end. And the beginning point of my shading should be when x is 140. So that's right here. So this is exactly the picture I just drew. It's a much better picture than I could draw, but it shows that the amount of shading to the right is 11.23%, or 0.1123. So this will be the answer to the B part of the question. The amount of the proportion of the curve that's shaded is 0.1123. So that would mean that 11.23% of people have high blood pressure. If I tried to set it up for the other picture, it would look like this. And so again, I could set, I want values of x above 1.21. That was the z-score that I had, because now this is the z-score distribution. And it will shade everything that's 1.21 standard deviations and above. And again, the same answer, 0.1. Could do that, it would look like this. To have this match the table, then I'm using the standard normal distribution, which is the distribution with a mean of 0, 0 in the middle, and standard deviation 1, meaning every tick mark is 1 unit. And just like I tried to draw, you can draw a vertical line at 1.21, that's the z-score for high blood pressure, and shade to the right by setting the upper tail probability with an x value of 1.21. So you'll notice that it's the same answer. It has to be the same answer. So we could say that's also the answer to the B part. It would be a totally different way of setting up the applet to get it, but it also would be valid. Now on the C part, the applet is much, much easier to use than the tables, because the applet allows you to set the applet up so that it shows you the shading between two numbers. And that's exactly what's being asked on the C part, part C of this question. So on the part C of the question, again, I've set my my applet back, I've set the applet back to have a mean of 123 and a standard deviation of 14. So that's this guy with the center at 123 and each standard deviation is 14. And they say, what's the proportion of people who have blood pressure between 102 and 140? And so I can just do that by saying type of probability is an interval and putting 102 and 140 in there, and it draws exactly the picture I want. It tells me that I have 82.09% shaded, which would be a proportion of 0.8209. So that's the answer to part C. If we were doing that with a table, then we would have to convert the 102 and the 140 to z-scores before we could use the table. I'm not going to try to illustrate that here, but if we do that, then we could get the two area readings from the table and then just subtract the bigger one minus the smaller one. And we should also get 0.8209. The D part asks us about the top 90%. And so to do this with the table, we'd have to read the table backwards, where we look for an area and then we find the z-score for that area. With the applet, and I'll show you that in a second, but with the applet, we can actually just go to this find percentile quantile tab, it's a different tab, and again set up my curve parameters, so mu and sigma, to make sure it draws the correct curve. And then I want to find, I want 90% to be in the lower tail. So I say lower tail is 90%. So this line would be the line on my distribution that cuts off 90% on this side and 10% on this side. So that blood pressure, 140.942, is going to be the blood pressure for the blood pressure cutoff for the 90th percentile. 90% of people have blood pressure less than that, 10% have blood pressure above that. So that's what we mean by 90th percentile. That could also be done in terms of the table, but just like before, I need my picture here to reflect a standard normal distribution, which means a 0 here for mu and a 1 for sigma. So let's see what that would look like. So here my mean is sigma, my mean is 0, my standard deviation is 1, so I get 0, 1, 2, 3, 0, negative 1, negative 2, negative 3. Again, I asked the applet for 90%, 90th percentile, and it tells me where to draw this line so that I have 90% shaded to the right. If you looked in the table for 90%, so if you look in the z-score table for the closest number you can find to that, then it will tell you this z-score. It'll say 1.28. Remember, the table can only give you 2 decimal places. So the table will say 1.28 is the z-score that gives me an area that's close to 0.9000. I do that by looking up this in the interior of the table and then reading off what z-score gives me that. If you do it that way, then you're in a situation where you have to convert back to blood pressures in order to be able to answer the question, because the question doesn't ask what's the z-score of the 90th percentile blood pressure rating. It says what is the 90th percentile blood pressure rating. So once I figured out that z is 1.28, remember my interpretation of this is the value I want is 1.28 standard deviations above, because it's positive, the mean. Right? That's literally what a z-score of 1.28 means. So to change that into a blood pressure rating, I need to take 1.28 times the standard deviation. So 1.28 standard deviations. Hang on, I'm not happy with my writing running together. 1.28 standard deviations would be that number. 1.28 times 14, because 14 is the standard deviation for blood pressure ratings, plus 123. That's the mean. So literally 128 standard deviations above the mean would be 128 standard deviations above the mean. So this will be the blood pressure rating that, that has a z-score of 1.28. And it should match the value that I just got on the previous slide. So whichever way you want to do it, that's your part D. That's your part D answer.